Last time we learned what a polygon is. Today we're going to talk about the angles inside of a polygon, identifying the interior and exterior angle measures and figure out how to find the sum of those angle measures. So let's first of all talk about how many degrees are in the interior. So the interior angle measures. So in order to do that, we're going to take a look on GeoGebra. And we're going to take a look here at the sum of the interior angles of a polygon. We already learned that there's 180 degrees in a triangle. And we can take a look at what happens as we increase the polygon. Four-sided figure has 360 degrees. Five-sided figure has 540. Six-sided is 720. And 900. 1080. 1260, and so on. Do you see any kind of pattern to those numbers as we go through it? Maybe it'd be helpful to write some of that down. I'll see if I can do that here. So three-sided figure has 180 degrees. Four-sided was 360. I'll write down the rest here. Okay, so looking at the table, what connection do you see between the sum of the interior angles as we increase the sides? Maybe you see that as the sides increase by 1, you know a pattern that's existing as the interior angles go up. You can see that the interior angles increase by 180 as we increase. So the question is, why is that working? Why does it do that? So the way we can figure that out is if we make triangles, because triangles have 180 degrees. If I split my square, my quadrilateral, into two triangles, 180 degrees in each one, that gives me 360. If I take my pentagon and divide that one up into three triangles, I now have 180 for each one. 180 times 3. And same with the hexagon, I can divide it into four triangles, 180 times 4. Heptagon into 5 triangles, 180 times 5. So hopefully you're seeing that connection there. And that's what we'll put down as our definition, is that when we have polygons, we can create triangles by creating diagonals. Diagonals are segments that join non-consecutive vertices. When I do that, I create triangles. And with this pentagon, I can create 3 different triangles. So 3 times 180 is 540 degrees. So if we want to generalize this, we can say the polygon interior angles theorem. The sum of the measures of the interior angle of a convex n-gon. So a 6-sided figure, I could create 4 triangles. 5-sided figure, I created 3 triangles. So it's always 2 less than the number of sides. So n minus 2. And triangles are 180 degrees, so I multiply by 180. That'll give me the sum of the angles. So measure 1 plus measure 2, all the way up to measure of angle n, is equal to n minus 2 times 180. That'll give me the sum no matter what size figure it is. And a quadrilateral, we saw, has 360 degrees because I can come up with 2 triangles within that figure. Okay, so let's apply that. We have 2 problems here where we need to figure out the sum of the measures, the interior angles of a convex octagon. An octagon has 1, 2, 3, 4, 5, 6, 7, 8 sides. And so 8 sides, I can form 6 triangles, 2 less than the number of sides. So if I draw on my diagonals, I have 1, 2, 3, 4, 5, 6 triangles. So n minus 2 times 180. So 8 minus 2 is 6 times 180. And 6 times 180 is 1080 degrees. Now, we want to find the measures of the interior angles of a convex polygon as 900 degrees. Classify the polygon by the number of sides. Well, we got to do a little bit of algebra. Well, I know the number of sides minus 2 times 180 gives me my sum. So if my sum is 900, Just got to reverse my algebra here. So divide by 180. And 900 divided by 180 will tell me how many triangles are in this figure. So n minus 2, that will equal, what is that? 5. So 900 divided by 180 is 5. So then I add 2. There's 5 triangles in the figure. So that must mean that there are 7 sides in the figure. So that would be a heptagon. Heptagon has 7 sides. Okay, so let's use some algebra now to find the missing value of x. This is a 4-sided figure. 4-sided figures have a sum of 360 degrees. So if I add them all up, x plus 108 plus 121 plus 59, and that will equal 360. There's 360 degrees in this figure. So I can divide it into 2 separate triangles. So if I add those all up, so 108 plus 121 plus 59 gives me 288. So x plus 288 is 360. And then I can subtract 288 from 360. And so I know x is 72 degrees. Okay, so that's for finding the interior angles. Next, let's explore how to find the exterior angles. That would be these angles if I were to extend the lines of each side. I'm going to figure out those angles. Those are all exterior angles. So let's go back into GeoGebra and take a look at that one. So the polygon exterior angles. Let's load up here. And if we're looking at a triangle, we know the interior angles add up to 180. So these 3 exterior angles, if I translate those angles over, notice, what is the sum of the measures of the exterior angles? Looks like 360 degrees. If I take a quadrilateral, I have my exterior angles highlighted. Let's dilate this figure, shrink it down, keep those exterior angles, 360. Pentagon, here's my exterior angles. If I translate those angles, voila, 360 degrees. Hexagon, maybe you can guess. Exterior angles, 360. This is pretty simple. Heptagon, 360. Octagon, I don't know, this one might be different. Nope, 360 degrees. So I think we pretty much satisfied the idea that it's going to be 360 degrees always, because what happens as these interior angles, what happens to size those interior angles? Those angles are increasing, which means the exterior angles are decreasing by that same amount. So exterior angles always have a sum of 360, because while they're getting smaller, we're adding another one each time. So the polygon exterior angles theorem states that the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So if I add them all up, no matter what size the figure is, it's going to be 360 degrees. So let's apply that here. Find the value of x. Well, I know these are all exterior angles here, so I can add them all up. And what will they equal? You got it, 360 degrees. So let's solve this equation now for 360. Maybe I'll let you solve it. Pause the video. Solve that one, then work on example 5. You want to find the measure of an exterior angle and an interior angle. Start the video when you're ready to see the solutions. Okay, so we finished solving that equation. 3x plus 156 equals 360. Subtract the 156, and then divide by 3 on both sides, x equals 68. Next one says we have the regular dodecagon, which means all the angles are congruent. It's a 12-sided figure. So we want to find the measure of each interior angle. Well, there's 12 sides, so 12 minus 2, because there's 10 triangles. 10 times 180 is 1800. So that's the total number of degrees in the interior angles. Since there are 12 congruent angles, I can divide that by 12, get 150 degrees for the measure of each interior angle. I know 360 degrees is the sum of all the exterior angles, and since there are 12 exterior angles, I can divide 360 by 12 to get 30. That would be the measure of one exterior angle. Another way I could do that, I could save myself a little bit of work, knowing that if there's 360 degrees always in the exterior, I could have just done 360 divided by 12 to get 30, and know that the exterior and interior angles are supplementary in a linear pair. So I could have just subtracted 30 from 180 to get 150, or vice versa. So use those connections that you know about those angles. And today we learned about how to find the sum of the interior angles. So find triangles, and then multiply the number of triangles times 180, and the sum of the exterior angles, which is always 360. So you'll apply that in problems where it asks to find any interior or exterior angle.